So let's discuss about some definitions and terms. Many of the terms we have discussed in the last two lectures. I think if you all go through that, the lectures, the before last or the first lecture, many of the terms related to the coordination compounds we already have a discussion there. But many of the other terms which are actually remain here, we can discuss in this lecture. First, for example, the first term is given here, coordination entirety. You are knowing about the central metal atom or ion which is associated or bonded by the coordination bond with the different species, that may be a neutral molecule having a lone pair or maybe an ionic species having a lone pair. Together they are called coordination entirety. This word actually indicating the single species having some coordination bond. This coordination entirety actually indicating the some single species or a single system, a particle having some coordination bonds in them. So this coordination entirety is just about the coordination complex only, where the one single central metal atom or ion is just bonded by a coordination bond with the different types of ligands. The same time, you can see here one more terms given, coordination sphere. Actually, coordination entirety and coordination sphere both are the same terms. That there is the only difference is when coordination entirety is enclosed in a square bracket, they are termed as coordination sphere. And the combination of central metal atom with the different species with a coordination bond is called coordination entirety. That is the basic difference between them. The next one, there is given one coordination polyhedron. This word actually indicating coordination polyhedron, that word indicating the arrangement, or you can say the spatial arrangement of the different ligands with the central metal atom in the different direction is called the coordination polyhedron. As you are knowing, suppose any coordination complex is a tetrahedral. Suppose any coordination compound, suppose here is a nickel and bonded with a carbon monoxide. So this arrangement, the three-dimensional arrangement of the ligands with central metal atom or ion in a space is actually called polyhedron. And this is one of the polyhedron that is actually here a tetrahedron. The same way, octahedral, square planar, trigonal, bipyramidal, these are the some spatial arrangements of the species in three-dimensional space or region with central metal atom or ion is called a polyhedron. This is the some generalization terms given are used for the coordination compounds eventually. Next word you are knowing about, in the last lecture also I have discussed about the coordination complex or coordination entirety actually consists of the two different things basically. The one is central metal atom or ion which act like a Lewis acid because can accept a pair of electron from the given species through the coordination bond. The second one is ligands which actually acting like a Lewis base because the lone pair of electron they are having that can be actually formulate or given to the central metal atom. So they act like a Lewis base. This word also given here, you have to go through that. Next word, that is the important one, what about ligands? In the section of ligands, there are actually many kind of terms given that you have to be learned before to going in a nomenclature section and the next section. Ligands, this special word is given for all those species having a pair of electron or ability to share a pair of electron to the central metal or atom. Students, ligands may be of many types. For example, here given unidentate, bidentate, tritetradentate, polydentate and ambidentate types. Ligands, the denticity means how many number of pair of electron they can be shared to the central metal is actually decide the denticity. For example, suppose we are having Cl minus, we are having NO2 minus. Look at some possibility. Look at some possibility here that can be actually explained on the basis of how many number of lone pair electrons they can be furnished to the central metal atom. One compound is there, acetylene. Students, one compound is there. Many other ligands that they carry only one lone pair, they can be donated to the central metal atom. Only one lone pair, they can be donated to the central metal atom or ion. They are actually called unidentate. Unidentate, that word stand here to be imparting a pair of electron, a single pair of electron by a single donor atom per ligand. Single donor atom there should be, and one lone pair electron they can be imparted to the central metal per ligand. They are called unidentate. Bidentate or didentate, that word actually stand for if the one ligand contains two different donor atoms, that they can be donate a two pair of electron per ligand. For example, you can see this Cn minus is unidentate, this is also a unidentate, and this ethane 1,2-diamine, or you can say ethylene diamine, having a two lone pair, because two different nitrogens are present, so they are called a didentate or bidentate, because one ligand can be share a two pair of electron. The next formula we can generate here, you can see the oxalate ion here. The oxalate means the two different oxygen having a minus charge that can be participate in the bonding, coordinate bonding with the central metal atom. So they also stand for here a didentate or bidentate ligands. Polydentate means generally the ligands must be carry more than 3 or 4 lone pair electron. They can be form a single bond, a single ligands. Here one more example. This one is also a bidentate or a didentate. But now one more example that is very important one. EDTA, ethylene EDTA na? What is the meaning of this? Ethylene, I mean that tetraacetate, ethylene diamine tetraacetate. So ethylene diamine tetraacetate, one of the molecule, one of the ligand here, that actually is a hexadentate. The one ligand can be give a 6 pair of electron. Let's see the formula of that. Ethylene diamine tetraacetate, in ethylene diamine tetraacetate, you can see the two different nitrogens having lone pair and 4 oxygen that carry a negative charge. All 6 these atoms actually participating in the coordinate bond formation. So one species, the one ligand of this ethylene diamine tetraacetate actually imparting a 6 pair of electron simultaneously to form a single coordinate complex like octahedral case. Like in the octahedral case, because in the octahedral, the central metal atoms generally actually bonded by the 6 different coordinate bonds. So these are the some types of ligands here. Unidentate, bidentate, you can see bidentate, this one is a polydentate, means hexadentate, and one another word is there, ambidentate. Ambidentate means the single ligand actually having two different donor atoms, but at the time one of them can only participating in coordinate bond. For example, this cyanide and NO2 minus during a combination, you can see the NO2 minus, that is called nitrite ion actually, either nitrogen atom participating in the unidentate bond formation or oxygen atom participating in the unidentate bond formation. Means in the same ligand, two different atoms can act like a donor atom, but at a time they behave like a unidentate. Two different atoms having a unidentate possibility. This is called a ambidentate possibility of the ligand. Ambidentate. So this is called nitrito N and nitrito O. During a naming, I will explain later, during a naming, the nitrogen and oxygen different atoms decide the naming possibility, the naming actually how we have to be right in the IUPAC naming. So this is this possibility called ambidentate, because two different atoms act like a donor atom in a same ligand, but at a time they behave like a unidentate only. This one is called didentate or a bidentate. This one is a polydentate. For that, this one is the example of hexa 1, and these are the examples of unidentate possibility. One more important, another important important terms are there. That is chelating. Actually, this is the process of the formation of cyclic structure of the coordinate complex with the ligands. Think about, if suppose there is a metal, if there is a metal and this metal bonded by this didentate ligand, so what will be the possibility? The possibility, you can see that whenever the didentate, tridentate or polydentate ligands attached with the central metal atom, they actually form a ring-like structure. Because of the closing of the ligands from the two different terminals or more than two different terminals. For example, ethane 1,2-diamine, you can see the two nitrogen atom when bonded to the metal, they just form actually a ring-like structure. A ring-like structure. So this ring-like structure, is called actually chelating. And you can see the complex ring-like structure can be formed by this hexadentate ligand, because at a time simultaneously all 6 atoms will bond it to the central metal atom, and from 6 direction there will be bonding, and that will be act like a single ring, a complex ring-like structure. One more important thing, that is actually they are asking about the board, comparatively unidentation possibility. Whenever there is a chelating possibilities occur that stabilize the coordination complexes, because the ring-like structure always are more stable than a single linear structures. So didentate, tri or polydentate, they just increase the stability of the coordination complexes because of the ring-like structure. These are the some terms given: unidentate, didentate, polydentate, chelating, ambidentate, and that denticity means the arrangement of the polydentate ligands to the central middle atom is called the denticity. Denticity word is just a meaning that how these ligands are coordinated, they are a pair of electron to the central middle atom or ion. That is just act like a denticity, that word here we are using. From this paragraph, you have to be learn some of the ligands like oxalate, ethane diamine, ethane 1,2-diamine are also called commonly ethylene diamine tetraacetate EDTA. These are ligands can stabilize the coordination complexes more than a single unidentate ligands. Next term is coordination number. Students, in the some previous last two lectures, we have discussed about coordination number is just a number that actually indicating how many number of coordinate bond formed by the ligands. Coordination number. How many number of coordination bonds are just formed? Just count these number bonds. That will give you a coordination number. For example, if any complex metal attached with 4 Cl minus, the coordination number will be 4, but the same metal attached with 2 this ethylene diamine, the coordination number again there will be 4, because the one ligand can form a 2 bonds, the 2 coordinate bond. You have to be just count the number of coordinate bond, not the number of ligands, because hexadentate this ligand, this ethylene diamine tetraacetate ligands, whenever the one ligand attached with the central middle atom, they will just form a 6 coordinate bond. It will just form a 6 coordinate bond. So it is called a coordination number 6. The 3 oxalate molecules will give us 6, and 1 this molecule will give us 6 coordination number. So you have to be just go through the how many number of coordinate bonds formed from the different ligands. These are called the coordination number. Next, about the oxidation number or the central middle atom. It is just a simple charge carried by a central middle atom or ion. If central middle atom does not carry any charge, that oxidation number called zero oxidation number. In the case of cationic, means in the case of whenever the metal act like a cation, it will have some oxidation number like a +1, +2, +3. As you know, silver can show a +1, iron can show a +2 or +3, cobalt +2 or +4, +3 also, nickel +2, +4. These are called oxidation number. During IPAC naming and nomenclature, these oxidation number must be enclosed in the parenthesis, that is called a small square bracket in a Roman number. Homoleptic and heteroleptic complexes. Homoleptic and heteroleptic complex. It's a very simple one, the word. Suppose I have one example. K4FeCl6. Suppose this example, potassium ferrocyanide. You can see the central middle atom bonded with the 6 same type of ligand, that is a cyanide ligand. All 6 ligands are a same type. That is called the condition of homoleptic complex. Homoleptic means the formation of coordinate bonds are actually from the same type of ligands, because all ligands are same. So this is called homoleptic. So you can imagine what is the meaning of heteroleptic, I think. You are getting my point. The heteroleptic means must be whenever there should be a different ligands. Means suppose the 5 CN and 1 Cl chloride ion लगा दिया जाए. When this complex contains 5 cyanide and suppose 1 Cl, this will be called heteroleptic, because now iron attached with 5 cyanide ions and 1 different types of ion, that is a Cl minus ion, chloride ions. So these are called heteroleptic complexes. These are the some terms given in the NCERT you can go through the ones where the different concepts are the same. Homoleptic, heteroleptic, denticity, chelating, polyhedron. These are the some special terms. The same time, you have to learn one more thing. Actually, polyhedron indicating the, as I said now, the arrangement of the ligands in the three-dimensional space. As you know now, octahedral arrangements are look like this. These are called octahedral arrangement, tetrahedral arrangement, triple bipyramidal arrangement, square planar arrangement. So you should learn at least these 4 types of arrangement, because frequently when we study the different examples of different complexes, there should be a different types of geometry that is called polyhedron, because how the ligands are especially arranged in the three-dimensional region or space called that. So octahedral condition, trigonal bipyramidal, tetrahedral condition and square planar condition. These 4 types of possibilities of geometry must be will come in the next upcoming sections during the formulations of the different examples. These are some special terms what we have to be study here today. We'll discuss about the nomenclature now. We'll discuss about the nomenclature. So this nomenclature will be a next lecture. Okay? We'll discuss nomenclature from tomorrow onwards. And in one lecture we'll discuss about nomenclature, then we'll start the next topics, whatever the next topic will be there. Okay, so I am concluding my lecture here only. Let first discuss about some doubts regarding to these topics. Okay.